So, yeah, so to find these interval of convergence, here's for a power series. To find the interval of convergence, step one is use the ratio test. Possibly, if it looks better to use the root test, then you could use that root test. It would accomplish the same thing. If the root test makes more sense. And then step two, and so that'll give you the start of an interval, okay? Because, like we said, the ratio test only gives you when it's less than 1. That's the only thing it gives you. Step two, then, we're going to use whatever test, test the endpoints separately from that interval. To determine if it's convergent at those endpoints. All right, so that's a two-step process. Ratio test, root test, and then test the endpoints. Now what can come up on intervals there are solving some absolute value equations, which we don't do a whole lot of, so let me just review a couple of solving absolute value equations. If I said, let's solve the absolute value of 3x minus 7 equals 13. Well, solving these really kind of hinges on the fact that you understand if you've got the absolute value of x is less than 1, that leads you to -1 is less than x is less than 1. And so an absolute value you can split that or rewrite it into a compound inequality like that. If it's the absolute value of x is less than another number, say 3, then you would do x between -3 and +3. Okay? So that's how you do simple absolute value inequalities where you have less than a number. Whoops. So what if I have the absolute value of 3x minus 7 is less than 13? I wrote equals before, but really what we'll come across are these, where you have the absolute value is less than a number. Well, judging by what we just said, since I've got 3x minus 7 is less than 13, I'm going to put 3x minus 7 between that -13 and +13. That's how you would solve that. All right. And then the goal is to get it where you have just x in the middle, and so that's just doing our regular thing. We're going to add 7 to both sides, left and right. Just do it all at once here. So that'll make me -6 is less than 3x is less than 20. Yeah, as long as you do it to all 3 parts, it's pretty legal. Divide by 3 now. So divide by all 3 parts by 3. That's -2 is less than x is less than 20 thirds. And so now you know what the x values lie between there. Now if I have a number, perhaps outside, or number multiplied by my absolute value there. Do the same thing. Probably the easiest thing though to do would be to, first of all, multiply by 3. Now to get rid of it here, you'll just have absolute value of x plus 5 is less than 12. And then you can do your between negative 12 and positive 12 thing. Subtract 5. You got it. Couple others though. What if we have the absolute value of x squared is less than 1? Well, isn't that still just going to be negative 1 to positive 1? Now, if we have that, well, first of all, the absolute value there is, we're talking about real numbers, and so the absolute values are not necessary for one thing there. Probably should have mentioned that on that one, but you're squaring the x, and so that's always going to turn out to be positive. So since we're talking about real numbers, we're not talking about imaginary numbers where you could get x squared to be a negative, but we're talking about real numbers. Now, x squared is less than 9. Yeah, you don't. Let's just think about it. X squared is less than 9.
X is less than 3.
You gotta have x is less than 3, but you could also have it, there is a limit to that. Yeah, it turns out, well, let's just think about numbers we could plug in there. Yeah, if I plugged in 2, that'd be less than 9. Anything up to 3, you're right. So x has to be less than 3. That is correct. But what if I did x is negative 4? That'd be 16. That's not less than 9, is it? So there's a limit down to it. What is it?
Negative 3.
It's negative 3, yeah. So if you've got x squared is less than a number, notice it's minus the square root of 9 to positive square root of 9, right? Just have to do that. The x is between the square root instead. Not going into a whole lot of detail there. I had this one. What about one more? So 2x squared is less than 1. Well, if you got that, I would go ahead and put it x squared is less than a half. Go ahead and divide by 2. And so what's x between there? Negative the square root of a half, positive square root of a half, right? So you do your square root off of that. So anyway, a little bit on square roots, those might come up. Any questions on that? All right, but back to finding, it's a 2-step process. Use a ratio test and then test those endpoints separately. Okay, so find the interval of convergence. With this power series, negative 1 to the n minus 1 times x to the 2n minus 1 over 2n minus 1. Okay. So step one is use that ratio test. The limit as n goes to infinity, absolute value of a sub n plus 1 over a sub n. Well, what the absolute value here, one of the things it contributes is it gets rid of that alternating sign, so we'll go ahead and get rid of it. Don't even write it down. The n plus 1 term, so I have 2x to the 2 times n plus 1 minus 1 over 2 times n plus 1 minus 1. That would be the a sub n plus 1 term. Then divide by a sub n means multiply by the reciprocal of the a sub n, so wouldn't it be this? With me? Okay. Well, that is x to the, that would be 2n plus 2 minus 1, so that would be 2n plus 1, divided by, that would be 2n plus 2 minus 1, so that would be 2n plus 1 as well. So what is all that going to simplify out to be? Well, good news is, yeah, this x to the 2n times x to the first, and then this is x to the 2n times x to the minus first. Split those out, because yeah, those x to the 2n's are going to cancel. Now, it's usually a good idea here to get the x's and the n's separated. So just kind of switch the tops out there. Separate those out. What's this going to do? What's that going to go to? 1. That's going to go to 1, yeah, 2 over 2. Yeah, if we divide by n there, whatever. That'll be 2 minus 1 over n over 2 plus 1 over n. Yeah, that's going to be zeros. Now that, what's that going to be?
X squared.
It's going to be x squared. Yeah, x divided by x to the negative 1 is the same as x times 1. X divided by 1 over x, which is x times x over 1. So that's x squared. We'll flip the minus 1 up, whatever. Yeah, so this is going to be, as n goes to infinity, this would be your absolute value 2 over 2, which is 1 times x squared. So that's just x squared, absolute value of x squared. Just the absolute value of x squared is just x squared. And I want, by ratio test, that less than 1, right? But we just talked about that. X squared is less than 1. That's going to be between square root of negative square root of 1, positive square root of 1 to
Negative 1.
yeah, that's negative 1. That's a start to it anyway. That's step 1. So step 2 then is we need to look at those endpoints. Check the endpoints for convergence. So again, it's the same 2 endpoints. They won't always be negative 1 to 1, unfortunately. But in this case, again, so just check them separate. So do x equals 1. So what we're meaning by that is we're just going into this series and plugging in x to be 1 and see what series that gives us. Well, 1 to any power is 1, so it's just negative 1 to the n minus 1 times 1 over 2n minus 1. Yeah, because that's 1 to anything is just 1. Yeah, so again, we do have alternating signs. So the alternating series test, if you've got alternating signs, that's, use that alternating series test, probably try it out. So alternating series test, what do you got? The B sub n's are decreasing, right? B sub n plus 1 is less than B sub n. I think we've got that. And then the limit. This is B sub n here. Yeah, I think we've got that, because that'd be 2n plus 1, that'd be 1 over 2n minus 1. Yeah, that's true. Put your denominator here. And then we need the limit of the B sub n's to be 0. And that's true too. So yes, that converges. What about x equals negative 1? Well, that's negative 1 to the n minus 1. There's negative 1 to the 2n minus 1 over 2n minus 1. Well, we can't just say that's 1, because now it's all, but I have this and this, so that's, notice what that does. That gives me negative 1, and then if I add these exponents, it's 3n minus 2. Well, again, I think these are alternating, that's going to be alternating signs. Let's see. If you plug in n equals 1, you got 1. Negative 1 to the 1 times 1 over 1. Then if we do the next one, it'd be negative 1, n equals 2, so that'd be the fourth. Yeah, so it is going to alternate here. So this is, again, alternating series test, which is basically the same thing. Converges. It's the same, basically the same series there. So both endpoints it converges. So we started off, step 1, we had negative 1, x is less, negative 1 is less than x is less than 1. But we saw that both endpoints now converge. And so the interval of convergence includes both those endpoints. So we get 1 extra. So that's what I'm saying. Sometimes both of them work, sometimes one of them works, sometimes neither of them work. And I can't remember in the book if they use the interval notation like that, or either one's perfectly fine. So, okay?
There are times where the endpoints won't be negative 1 and 1.
Huh?
There are times where the endpoints won't be negative 1 and 1.
Yes. Yes. Just our first two have. I think the next one will give us one of those.